What if I told you that the ultimate dietary boogeyman of the 1990s, the one food we were practically ordered to banish from our breakfast tables for fear of our hearts, is actually dispatching biological tow trucks to clean your bloodstream right now?
I mean, it is just a complete inversion of how we spent decades looking at breakfast.
Right.
Yeah, and it gets straight to the heart of how often we mistake a food's reputation for its, you know, actual biochemical function inside the human body.
Which is exactly why we're here.
Mm.
Welcome to this deep dive. Today, our mission is to unpack the physiological domino effect of a highly specific, deceptively simple daily habit.
And it is a fascinating one to look at.
It really is. So for you listening, whether you're trying to optimize your morning routine or just wondering if your breakfast is working for you, we're analyzing a really concise, incredibly dense breakdown from Dr. Sethi.
Right.
He details exactly what happens if you eat eggs daily for 2 straight weeks. And we aren't just looking at a list of generic health claims. We want to understand the why and the how.
Exactly, because the mechanisms matter.
Yeah, how this single ingredient food acts as a catalyst across entirely different bodily systems, from the lenses of your eyes to the lipid metabolism happening deep inside your liver.
And, the time frame he sets up, those 14 consecutive days, is where the actual science really begins to reveal itself.
Yeah, why 14 days specifically?
Well, because a single meal is just a drop in the metabolic bucket, right?
Mm,
But a 14-day continuous daily influx of a specific nutrient profile, well, it forces the body to adapt.
like it establishes a new baseline.
Exactly. It's a biological window long enough for cellular turnover and enzymatic shifts to reflect a new baseline of nutrient availability, but short enough to act as a highly measurable experiment for anyone listening.
Okay, let's unpack this, starting with the literal structural foundation of the body. Dr. Sethi's text goes straight for the architecture, stating that eggs provide the best quality protein, supplying our muscles and our connective tissue with essential amino acids.
The foundational building blocks.
Right. Now, whenever we talk about amino acids, the default analogy is always Lego bricks.
Yeah, always.
But I think that's too simple for what's actually happening over a 2-week period. I prefer to think of essential amino acids as a highly specific biological alphabet.
Oh, I like that.
Right. Because if your body is trying to write the instruction manual to build or repair a tendon, it needs all the letters. If you're eating incomplete proteins, it's like trying to write a complex technical manual without using the letter E.
Machinery just halts.
Exactly. The cellular machinery just stops. It cannot finish the sequence.
That alphabet analogy perfectly illustrates the concept of best quality. I mean, in clinical nutrition, when a source describes a protein as high quality, they're referring to a complete bioavailability profile.
Meaning you get every single letter.
Precisely. It means this specific food matrix contains every single essential amino acid, the ones the human body absolutely cannot synthesize endogenously, in a ratio that perfectly mirrors human physiological requirements.
So what happens when it hits the stomach?
Well, when that egg hits the highly acidic environment of your stomach, hydrochloric acid and an enzyme called pepsin basically begin unraveling those complex protein structures into smaller peptide chains.
Just breaking them right down.
Right. And as those pass into the small intestine, they're further cleaved into individual amino acids, absorbed through the intestinal wall, and then dumped directly into the portal vein.
Wow. So within a couple of hours of breakfast, you have this massive influx of raw biological letters circulating in your bloodstream, just waiting to be assembled into new tissues.
Ready for deployment.
Yeah. And the part of Dr. Sethi's breakdown that caught my eye wasn't even the muscles. It was his explicit mention of connective tissue.
Which is often completely overlooked.
Right. Everyone associates protein with a bodybuilder growing bicep fibers. But connective tissue is, like the tendons, the ligaments, the fascia wrapping our organs.
And this is where the 14-day timeline becomes totally critical. You see, muscular tissue is highly vascularized.
Meaning lots of blood flow.
Exactly. It has a massive blood supply, meaning it receives nutrients and repairs itself relatively quickly. Connective tissue, on the other hand, is largely avascular.
So it's the opposite.
Right. Tendons and ligaments have a very poor blood supply, which is why, like, a torn Achilles takes exponentially longer to heal than a torn calf muscle.
Oh, that makes so much sense.
Yeah. The cells responsible for maintaining connective tissue, the fibroblasts, they operate at a much slower metabolic rate because they're essentially nutrient-starved most of the time.
Okay, so if I'm tracking this correctly, eating a high-quality protein just once a week wouldn't do much for a tendon,
Not at all.
because by the time the fibroblasts finally ramp up their repair processes, the amino acid supply in the blood has already been cleared out by the muscles and the liver.
You've hit on the exact mechanism of the 2-week habit.
Wow.
By consuming this complete amino acid profile every single morning for 14 days, you are fundamentally altering the nutrient environment of the bloodstream.
You're just constantly restocking the shelves.
Exactly. You're preventing the body from ever entering a state of amino acid triage where it has to, decide whether to prioritize a muscle repair or a vital organ function over a nagging tendon injury.
It doesn't have to choose anymore.
Right. Over 2 weeks, you saturate the blood plasma with these essential letters. The fibroblasts in your connective tissue finally have a steady, continuous, unbroken supply line.
So they can actually get to work.
Yes. They shift from a state of mere survival or slow degradation into a state of active collagen synthesis and structural reinforcement.
Which means this 14-day experiment isn't just a fitness hack for your gym routine. It's a structural maintenance protocol for your entire chassis.
It really is.
You are actively armoring your joints and your internal scaffolding. And actually, speaking of armoring the body against degradation, the source material takes a pivot that I found genuinely shocking.
Yeah, it takes a fascinating turn here.
Because it moves from structural repair directly into sensory health.
The connection to the visual system is profound.
Here's where it gets really interesting, because the text explicitly claims that this daily habit helps prevent macular degeneration and cataracts.
Right.
And I look at an egg on a plate, and I do not see an optical shield,
Most people wouldn't.
I've been conditioned to think about carrots or dark leafy greens for eye health. How does a breakfast staple physically intervene in the aging process of our eyes? We're talking about preventing physical degradation of the biological hardware here.
If we connect this to the bigger picture, we really have to look at the structural vulnerabilities of the eye itself.
Yeah.
The macula is this small, highly sensitive area at the center of the retina. It's responsible for sharp, detailed central vision.
The really important stuff.
Exactly. And it is constantly bombarded by light, particularly high-energy blue and ultraviolet light, which generates massive amounts of oxidative stress.
Just from keeping our eyes open.
Just from existing in the world.
Yeah.
And this oxidative stress produces free radicals that essentially rust the cells of the macula over time.
Like actual biological rust.
Pretty much. And that is macular degeneration. Similarly, the lens of the eye is made of specialized proteins. Under oxidative stress and natural aging, those proteins can denature, clump together, and turn opaque.
And that clumping is a cataract.
You got it.
It sounds like the visual system is under a constant, unavoidable environmental assault. So how does this specific 14-day nutrient influx stop the rusting of the macula and the clumping of the lens proteins?
Well, the eye has a highly selective security checkpoint called the blood-retinal barrier.
Kind of like the blood-brain barrier.
Very similar, yes. It prevents most substances in the bloodstream from entering the delicate ocular tissues. But the implication in Dr. Sethi's text is that the specific lipid and nutrient matrix within the egg contains compounds that are basically granted VIP access across that barrier.
It's just waving them right through.
Exactly. And once inside the eye, these compounds like lutein and zeaxanthin accumulate heavily in the macula and the lens.
So they just post up in there.
Yes. They physically absorb the damaging blue light before it can strike the retinal tissue. They act as internal biological sunglasses.
That is so cool.
At the same time, they neutralize the free radicals, stopping the oxidative rust before it can degrade the cells or denature the lens proteins.
It's compounding interest on your sensory longevity.
That's a great way to put it.
You aren't just taking a pill to fix a problem after the fact. Over 14 days, you're saturating those ocular tissues, layering on microscopic shields every single morning.
It's totally preventative.
It completely reframes how I think about a daily habit.
Yeah.
It's a preemptive strike against aging. And as we trace these biological supply lines from the eyes down into the deeper internal systems, Dr. Sethi brings up a nutrient that feels like it has zero public relations team behind it.
Oh, absolutely. We are looking at a compound that governs functions across entirely disparate systems.
We're talking about choline.
Yes,
The
choline.
source states that eggs are high in choline, which supports brain health and helps prevent fatty liver. Now, choline isn't a flashy buzzword.
No, it's pretty obscure for most people.
Right. But if we picture the body as a massive corporate enterprise, choline is essentially pulling a double shift.
How so?
Well, it acts as the elite IT department up in the executive suite. The brain, keeping all the servers communicating.
Right.
And then it puts on a pair of overalls heads down to the basement, the liver, and acts as the heavy machinery cleaning crew to keep the metabolic factory from shutting down.
I love that analogy. What's fascinating here is the dual action nature of choline. It is one of the most incredible aspects of human biochemistry. Let's dig into the IP department first.
Okay, let's analyze the neurological level.
Hmm.
The human brain operates on a vast, complex network of electrochemical signals. For one neuron to fire and communicate with the next, it uses chemical messengers called neurotransmitters.
Right.
The text states that choline supports brain health, which points directly to its role as the primary building block for acetylcholine.
Acetylcholine.
Right. And acetylcholine is the specific neurotransmitter responsible for memory formation, focus, and overall cognitive signaling speed. So without a steady supply of choline, the IT department is completely understaffed.
Exactly.
The brain can't manufacture enough acetylcholine, so the electrochemical emails start dropping. The network slows down, which we experience subjectively as, like, brain fog or an inability to sustain focus.
Yes, and it goes even deeper. Beyond the neurotransmitters, choline is also a vital structural component of the phospholipid bilayer.
Which is what?
It's the actual protective membrane that surrounds every single cell in the brain.
Oh, wow.
So a 14-day continuous supply ensures that not only is the signaling chemical abundant, but the physical hardware of the neurons is being constantly repaired and maintained.
The IT guys are fixing the software and the hardware.
Exactly. Now contrast that highly delicate neurological work with what choline is doing hepatically down in the liver.
Basically, a cleaning crew.
Right. Dr. Sethi specifically notes it helps prevent fatty liver.
And the liver is the body's central processing plant. If I understand the mechanics of fatty liver disease, it happens when the liver is processing dietary fats and synthesizing new fats, but it can't figure out how to ship them out to the rest of the body.
The shipping department breaks down.
Yeah, the loading dock gets backed up,
Yeah.
and the fat physically accumulates inside the liver tissue, literally choking the organ.
That accumulation is called hepatosteatosis, and the specific mechanism that prevents it relies entirely on choline.
How does it fix it?
Well, for the liver to export fat triglycerides into the bloodstream to be used as energy by the muscles, it has to package those fats into specific vehicles. These are called very low-density lipoproteins, or VLDLs.
Okay, VLDLs.
And choline is the absolute limiting factor in the creation of those VLDL vehicles. It is the molecular forklift driver.
Ah, I see.
If you have an abundance of fat in the liver but a deficiency in choline, the VLDLs simply cannot be formed. The fat is trapped.
So by initiating this 14-day protocol, you're basically flooding the loading dock with forklift drivers.
You're fully staffing the warehouse.
You are providing the exact chemical catalyst the liver needs to package up its triglycerides and export them safely, ensuring the hepatic assembly line stays completely clear and optimized.
It reveals the deep underlying interconnectedness of our biology. We artificially separate our organs when we think about health, you know?
Right, like the brain does this, the liver does that.
Exactly. We think the brain does the thinking and the liver does the detoxing. But this source material demonstrates that cognitive function at the very top of our nervous system and lipid metabolism deep in our gut are both pulling from the exact same chemical resource pool.
That is wild. And since we are already down in the basement discussing how the liver processes and packages lipids, that leads us directly into a transition we just cannot avoid.
We have to go there.
We have to talk about the most controversial element of this specific food.
The ultimate nutritional boogeyman.
So what does this all mean? Let's confront the contradiction. Dr. Sethi's text states plainly, quote, "While eggs are high in cholesterol, they can raise your good HDL levels."
Right.
For the vast majority of our lives, the public was explicitly instructed to avoid this food precisely because it was loaded with cholesterol.
We were told it was poison.
Yeah, we were told it was a direct one-way ticket to arterial plaque and heart disease. If this food is inherently high in a substance we've been taught to fear, how can the text confidently recommend we eat it every single day?
This raises an important question about how our scientific understanding of lipid transport has evolved. And honestly, how dangerously oversimplified our language around cholesterol became.
It was just demonized.
Completely. Let's deconstruct this narrative strictly using the physiological parameters implied by Dr. Sethi. The source acknowledges the high cholesterol content right up front.
He doesn't hide it.
No, but the crucial insight is the elevation of high-density lipoprotein, the HDL. To understand why this matters, we have to look at how the body actually handles dietary cholesterol.
Right, because for decades, the assumption was a 1-to-1 ratio. You eat a gram of cholesterol, it goes straight from your stomach into your arteries and clogs them like grease in a pipe.
Which we now know is biologically inaccurate. Cholesterol is not inherently a toxin.
No.
Not at all. It is a vital structural molecule required to build cell membranes and synthesize hormones like testosterone, estrogen, and cortisol.
The body needs it to function.
It absolutely
Yeah.
relies on it, and the liver tightly regulates the amount of cholesterol in the blood. When you consume dietary cholesterol, the liver senses it and downregulates its own internal production to maintain homeostasis.
Oh, so it just pumps the brakes on making its own.
Exactly. But the real magic happens in the transport system. Cholesterol is a fat, meaning it is hydrophobic, it repels water.
Like oil in water.
Right, it cannot float freely in the watery environment of the bloodstream. It has to be carried by protein submarines called lipoproteins.
And this is where we get the LDL, the so-called bad cholesterol, and the HDL, the good cholesterol. But I hate those terms because they aren't different types of cholesterol, right?
That's spot on.
They're just different transport vehicles carrying the exact same cargo.
That is a vital distinction. Low-density lipoproteins, the LDL, they carry cholesterol from the liver out into the body to be used by the cells.
The delivery trucks.
Right. If there is too much LDL, or if those particles become oxidized, they can penetrate the arterial walls and trigger an immune response, which leads to plaque buildup. But the text focuses on high-density lipoprotein, HDL.
Okay, so what does HDL do?
HDL is the reverse transport mechanism.
Okay, so if LDL is delivery trucks dropping cholesterol off at the tissues, HDL is the fleet of tow trucks cruising the highways looking for excess or stranded cholesterol.
The technical term is reverse cholesterol transport, but I love the tow truck analogy.
Yeah.
HDL particles physically interact with macrophages' immune cells in the arterial walls.
And they just pull it out.
Yes, they pull the excess cholesterol out of those tissues, lock it inside their protein shell, and tow it all the way back to the liver.
Wow. And then what?
Then it gets broken down and excreted from the body via bile. What Dr. Sethi is pointing out is a profound biological adaptation.
Meaning the egg actually helps this process.
Exactly. The specific nutrient matrix of the egg, the high-quality proteins, the specific fatty acids, and yes, the dietary cholesterol itself, it acts as a signaling mechanism.
Telling the liver what to do.
Right. It triggers the liver to synthesize and release more HDL tow trucks into the bloodstream.
Which completely neutralizes the fear.
Yeah.
I mean, you aren't just dumping cholesterol into the system. You're actively upgrading the body's internal clearance infrastructure.
You're expanding the fleet.
Over a 14-day period, if you're continuously stimulating the production of HDL, you are dramatically improving your lipid clearance capacity. It replaces a generic, generalized fear of food with a functional understanding of your own biochemistry.
It proves that the body's response to a whole food is a highly orchestrated adaptive symphony, not just some crude blumbing problem.
Man, that's amazing. Now, upgrading your reverse cholesterol transport and armoring the macula of your eye are incredible systemic benefits.
Undeniably.
But they are entirely invisible.
Yeah.
You don't consciously feel your liver exporting VLDLs on a Tuesday afternoon.
True, you can't feel your HDL levels rising.
Right. So we need to talk about the subjective experience of this 14-day protocol. For the person listening, how does this actually change the way you feel while sitting at your desk or managing your kids?
That brings us into the realm of endocrinology and energy management.
Let's dig into that. Dr. Sethi notes that eating eggs for breakfast helps stabilize blood sugar, keeping you energized throughout the day.
A huge benefit for daily life.
Now, we are talking to an audience that understands the basics. We all know that eating a bagel or a giant bowl of sugary cereal causes a spike and a crash.
It's the classic sugar roller coaster.
We know that paper burns fast on a campfire and leaves you with cold ashes, whereas a dense protein source acts like a slow-burning oak log.
That's a perfect way to visualize it.
But I want to bypass the basic sugar makes you tired explanation. Let's look at the actual hormonal levers being pulled over this 14-day timeline. What is the continuous influx of complete amino and fatty acids actually doing to our baseline insulin sensitivity?
If we dive into the endocrinology, we have to look at gastric emptying rates and the incretin effect.
Okay, walk us through that.
When you consume a breakfast high in refined carbohydrates, it passes through the stomach and into the small intestine incredibly rapidly.
Like almost instantly.
Pretty much. This causes a massive, violent surge of glucose into the bloodstream.
And the body freaks out.
The pancreas panics. It releases a tidal wave of insulin to shove that toxic level of glucose into the cells, which results in the precipitous blood sugar crash 2 hours later.
The dreaded 10 a.m. slump.
Yes. The brain fog, the lethargy, the desperate craving for coffee. It's the biological panic of a sugar crash.
But when you eat a dense, complete protein and fat matrix first thing in the morning,
The stomach physically slows down. It drastically reduces the rate of gastric emptying.
because it has to work harder to digest it.
Exactly. The protein and fats require significant enzymatic breakdown before they are allowed to move into the small intestine. This means any glucose from your meal is drip-fed into the bloodstream at a slow, tightly controlled rate.
No violent surges.
Not at all. The pancreas doesn't panic. It just releases a small, measured amount of insulin. But over a 14-day period, the systemic effect of this daily stabilization is profound.
Because you are basically giving the pancreatic beta cells, the cells that produce insulin, a 2-week vacation from chemical emergencies.
You are shifting your entire baseline insulin sensitivity.
How does that feel, though?
Well, when your cells are not constantly bombarded by massive insulin spikes, their insulin receptors become highly sensitive and efficient.
You don't have to shout to be heard over the noise.
Right. And the body stops relying on sudden rushes of exogenous glucose for energy. Instead, it becomes highly adept at mobilizing stored energy, like liver glycogen and body fat, to maintain a perfectly flat, stable energy baseline.
That is the ultimate tangible payoff for anyone listening.
Absolutely.
If you are preparing for a marathon of meetings or you just want to avoid that crushing 2:00 p.m. slump, you are utilizing this specific food to mechanically enforce a slow gastric emptying rate.
Which flattens the glucose curve.
Right, which optimizes your insulin response.
Which results in a continuous, unwavering supply of cellular energy.
The 14-day timeline allows the endocrine system to unlearn the chaos of a highly processed diet and settle into a rhythm of sustained metabolic output.
It's an incredible reset for the whole system.
This cascade of benefits is astonishing. But there is a massive biological elephant in the room that we have to confront here.
Let's hear it.
Because what if you, listening right now, want every single one of these systemic benefits, the stabilized baseline energy, the HDL tow trucks, the choline-powered liver clearance, the structural scaffolding for your tendons, but you simply do not consume animal products?
It's a very valid concern, and the text anticipates the specific dietary parameter and provides a highly specific alternative.
Yeah, Dr. Sethi concludes his breakdown by stating that the best vegetarian or vegan alternative to eggs would be tofu.
He singles it out specifically.
And I have to stop you there and push back hard on this. Dr. Sethi is a medical professional offering a biological substitute, but tofu is a pressed block of coagulated soy milk.
That's what it is, yes.
And an egg is a complex animal product. From a purely biochemical standpoint, I have a really hard time believing my liver, my brain, and my endocrine system treat those two vastly different things identically.
It sounds like a stretch on the surface.
Right. Is he just oversimplifying this for the sake of offering a polite vegan option? Or is there actual biochemical parity here?
It is the right question to ask because a true proxy must deliver the exact same biochemical payload. Dr. Sethi doesn't suggest eating almonds or black beans or some highly processed plant-based meat substitute.
He specifically isolates test tofu.
Yes, and the biochemistry of soybeans validates that choice. Let's look at the most critical factor, the biological alphabet we discussed earlier.
The essential amino acids for the connective tissue scaffolding.
Right. Soy is entirely unique among legumes and plant sources because it contains a completely whole, intact, essential amino acid profile.
So it has all the letters.
It provides every single letter of the alphabet required for those fibroblasts to continue collagen synthesis. The bioavailability is exceptionally high, mirroring the best quality requirement needed to prevent the body from entering that amino acid triage state.
Okay, so the structural maintenance protocol for the tendons and ligaments survives the transition to tofu.
It does.
But what about the endocrinology? Does a plant-based block of soy actually mimic the slow gastric emptying rate and the stable insulin response? I mean, it's a plant?
It does. Because of the specific macronutrient matrix of traditional tofu, it is incredibly dense in protein, but crucially, it is also rich in healthy plant-based fats while containing almost zero easily digestible carbohydrates.
Ah, so it triggers the same brake pedal in the stomach.
Exactly. When tofu hits the stomach acid, it demands the same slow, laborious enzymatic breakdown process. It enforces that identical delayed gastric emptying rate,
preventing the glucose spike.
Keeping the pancreatic beta cells calm and shifting the body into that same long-term stabilized energy baseline over the 14-day period.
It is a fascinating biological loophole.
Isn't it?
The source materials is essentially proving that the human body is entirely agnostic about the origin of its fuel.
It really is.
The body doesn't care if the molecular payload came from an animal or a plant cell wall. It only cares about the biochemical math.
The raw data.
Yeah. If the food delivers a complete amino acid profile, forces a slow gastric emptying rate, and provides the necessary lipid transport building blocks, the 14-day domino effect will initiate regardless of dietary philosophy.
The mechanisms of structural repair and endocrine stability are universal, provided you supply the correct biochemical catalysts.
We have covered an immense amount of ground today.
We really have.
What began as the 74-word excerpt from Dr. Sethi about eating eggs for 2 weeks has unspooled into a masterclass on human physiology. We've seen how this daily habit acts as a continuous supply line of biological letters, allowing our connective tissue fibroblasts to actively rebuild our internal scaffolding.
And we examined its role as a proactive shield, delivering specialized compounds across the blood-retinal barrier to neutralize free radicals and prevent the structural degradation of the macula and the lens.
We tracked the dual-action power of choline, synthesizing acetylcholine for cognitive focus, while simultaneously forming the VLDL transport vehicles needed to prevent fat accumulation in the liver.
The IT department and the basement cleaning crew?
Exactly. We deconstructed the outdated cholesterol panic by understanding how this food actively recruits HDL tow trucks to clean our arterial highways. And we explored the endocrinology of gastric emptying, seeing how a dense protein matrix stabilizes our insulin receptors to provide an unwavering, crash-free baseline of energy.
And finally, we validated that this entire intricate biological symphony can be perfectly mirrored through a precise plant-based proxy, confirming that optimal human function relies on specific biochemical payloads, not just dietary labels.
It fundamentally changes how you look at the food on your plate. And it leaves me with a final, provocative thought for you to carry with you long after this deep dive is over.
I'm ready.
We have just spent an hour mapping out how 14 days of a single, incredibly simple dietary habit can initiate a profound, cascading upgrade across your entire physical and cognitive operating system. If a basic, unpretentious breakfast staple holds this much systemic transformative power, what other common everyday foods are sitting quietly in your pantry right now, secretly possessing a similar multi-tool capability that you have completely underestimated?
It really suggests our kitchens are filled with deeply powerful biochemical levers, just waiting for us to understand how to pull them.
What a fantastic concept to explore on your own. Thank you so much for joining us on this deep dive. Keep questioning the world around you, keep looking closely at the hidden mechanics of your daily habits, and we will see you next time.